So Hemendra Talisara is working on with some startups, BitStar Technologies, Panorama Design, and others, where he's an advisor. Okay, Hemendra is a known name in verification with over 35 years of experience. He worked for IBM, Synopsys, AMD, and many others, and led many projects through the entire verification lifecycle, architecture to design, implementation to tape out. His projects include CPUs, GPUs, wireless networking, telecoms, solid-state devices, and various peripheral IPs. He's a certified corporate director, advisor, and mentor to startups, deeply involved into disruptive and transformative technologies, technical and societal impact. He will explore the implications of next generation AI on verification processes. And I'll invite Hemendra to the stage now. Thank you. And I will give you a mic. Do you want to put that on? Interesting. Okay, sorry. Oh, I should have probably done this in advance, shouldn't I?
How much time I have? 30 minutes.
Sorry? 45. I'll give you a 10-minute warning, don't I? Okay, let's just click that on. I'll click that on for you. Okay, and then you need to turn it on. That's the other thing. Okay.
Hello, can you hear me?
There you go.
Thank you. Thank you, Mike. Known Mike for 20 years. I was very excited when he asked me to talk about, to give keynote here. And lately, I have been working on keeping up with new technology, AI and Gen AI and so on. So I want to talk to you guys. Before I do that, I see a lot of familiar faces, many I talked to earlier today and last evening. Many I will talk to you later in the day. So good to see you guys. The reason, before I talk about the talk, I just want to introduce 2-3 things here. So Panorama Design is a company, Austin-based company, that was created by Matt Genovese. A lot of people know him. He used to have a thing here. Right now he's in Brazil, but it does software documentation, AI-based tools. And one of his passion was verification. So he's done some verification work as well. And I'll talk about that.
There's no video.
BitStar is a small startup in Bangalore that does small modules for self-driving cars, mostly for Germany and Japan automobiles. They both have a services arm that they do services, but BitStar doesn't have much presence in US. And Second Voice is kind of a pre-announcement. I talked to a lot of people. It's a mentorship for a lot of graduate students who are getting into industry or people who are changing careers. It's a non-profit, no cost, custom mentorship service available for career track. The Second Voice is the idea of listening to your fearless voice who dreams, who just doesn't want a one-track career, may have multiple aspirations. How do you put it all together? So it's a mentorship service that I'll announce later, but just a pre-announcement. I just want to let you guys know. That's the introduction from there. So lately I have been more into board governance stuff, and AI has been, I did some work on digital transformation, how the company needs to do that. And my background being verification, it always brings it back to me. So today I'm going to talk more on the verification impact and how the leadership needs to adapt to the new technology. So this is the general outline. I'll go through a few headlines just to get us on the same page as what the big buzz is, why people are, who's doing what, and then what's the verification cares about. And then we'll talk more on Gen AI, some fundamentals. Knowing that is important for purpose of understanding how to use it. Because you really need to know what is it where Gen AI works well, where it doesn't work, and how the industry is looking at, especially the software industry, because the verification and software are very similar in many ways. So, and then what's the lesson for the leadership? What they need to do to transform their group, their team, their organization. So that's the theme of it. So let's just quickly look at the headlines. This is just talking about the market size. The compound growth projected is like 80+% by 2033. So this is not just hardware chip design. This is the entire marketplace change. Like everything today is going to change in few years. There is no industry, no job that is not going to be impacted by Gen AI. Almost everything. And the only question we have to ask, will we remain will we continue to do the old ways, or there are things for us to think about? This is some other headlines that you might have seen in these journals and websites, which says that the chip design is drawing new startups. The bottom one clip shows that AI chip design, which is currently at about $2 billion, is going to grow 14x in less than 10 years, 7-8 years. So it's a huge change. The energy, the money, the dollar, everything is going towards it. So it's going to impact everyone. As you be the user or be the developer of it, you will be impacted by it. This is again another headlines. It's just saying that the Google is using DeepMind to change their design process. They don't want to rely solely on engineers alone. So you're not getting replaced, you're getting augmented. One of the things is we have found the resources always short. You're needing help, you can't hire those people. We have struggled with that. So the AI may come to aid. This is NVIDIA. If you look at this, it says custom LLM called ChipNemo. They have their own LLM based, and I will talk a little bit about LLM in a second. I haven't introduced the word, although you guys know about it. So they have their own LLM, they have their own design process, they have all verification process that they are using today. So this is something I met this guy in another conference a couple of months back in San Jose. And so the NVIDIA is full, he's saying is the return on investment is very high for what they're doing. And it's only, they have only taken 2 or 3 limited projects as a pilot, and they're seeing good returns on it. So the question is, can we ignore it or should we embrace it? So that's the thing we want to. Now, what does verification about? 2 things. They want first pass silicon, and they don't want any showstopper bug. That's always the case. And constraints always has been shrinking schedule. You don't have enough budget. You don't have enough resources. That has been the story for last as many years. Last 40 years I have worked in this industry. The story hasn't changed. And the means have changed a little bit, but they are incremental in many ways. So tests, regressions, debug, coverage closure, formal reasoning, compliance to the requirements, legacy and reuse. So this is a general thing, broad picture of how the verification works, how the verification flow works. So the question is, can Gen AI help? So I just noticed something. I had sent them an updated version yesterday of slides. It's a 2-3 days old version, but I might have to skip few things in here just to make sure that we have stay. Because I had too much detail in the slide and I'm going to skip some of it. I was reviewing with my colleague and he says that you're going to lose half the audience. So I want to keep it at a level where all of us are on it. So this particular thing, the important point I want to make is why Gen AI is a game changer. Things are changing big time. So it's beyond the predictive analytics where you can predict. Now you can create new content. That's the main thing. And you create new content without programming, without giving it any instruction whatsoever. So that's a very important piece. And how it does it, we're going to look at a little bit on that. You can create out-of-the-box thinking solutions. And I have gone through many, and you might have heard of many things here. Recently, there was some study where they designed a new car using AI, which comes up as a car because of the driving habits, how many turns it takes to the left, how many takes to the right. It comes up with a chassis design that is something we can't even imagine. Completely out of box because humans can think about 10, 20 alternatives and they try to fit find the best combination in those 20 to come up with a new design. Gen AI has billion parameters. It thinks of things that you cannot even imagine. And that's a very important thing. Feeds on digital data, which is very big today. So because of internet, all the data is digital. Unfortunately, it's mostly in the West. Most of the internet is in English language. There are a lot of biases, especially gender biases, racial biases that are all built into it. All the good, bad, ugly, everything is on the internet. But the amount and quantity, the big data is available. And that really created, and the fact that we have computes today to process it really changed how Gen AI works. We'll talk a little bit about deep learning here, but for example, ChatGPT has all the information on public web on the date of its creation, millions of books. So if you think about one book of 200 pages, about 100,000 tokens that is processed by, say, ChatGPT. Now, if you have a trillion token, that's like a 10 million books. So the amount of information, you and I can't read it. If a model has read or digested that level of information, that's a huge amount of information to process and so on. So one of the things is that every millions of books, publication digital, including Verilog code. And we have some demo here, which I won't go through, but I'm going to send you a link for you, where we created something from log and specs, RISC-V specs to show you how the test bench created and how test generations get created using Gen AI. But the amount of data that is available in this in public domain is not very much. And Gen AI primarily works on feeds on data. So the amount of data required for training is minimal in this particular space. So the toy models work very well, but we need more data to train it better using our specific domain. So plenty of proof points are saying process automation industry has gone big. A lot of things you have. There's a new now. A lot of new products are coming up because of Gen AI as well, and that's a big thing. One of the things you will see, and that will be part of the link I'll send you, that when you have a partner, if Gen AI can be another engineer for you, if there is a application that acts like another verification engineer who sits next to you and writes code with you, that's very powerful. If you have done pair programming, you know the power of it. And that's a huge, big thing. One thing we have all struggled in verification is we never get access to the architect. Yesterday, I was talking at lunch to somebody. He says, I went to that designer. He says, come back a week later. I don't have time this week. I have a deadline to meet. The verification guy is stuck, not understanding the spec at a certain level. Now you have another person who understands your spec, who can help you right away on your desk without waiting a second. So that's a real power to have it Gen AI as your assistant, as your colleague, whatever you like it. So 4 areas, there are about a dozen areas I saw with very high ROI return. The top 4 included software engineering and R&D. And that's really the return we are looking for in verification as well. So that's the piece I'm going to talk about because verification has much common with software. So general purpose technology, multitude of applications. I was reading yesterday some article, there's a antibiotic called helicin, was discovered by MIT in 3 days. And after reading at least 100 million medical journals, that they claimed it's very difficult to discover antibiotics. It has the least impact on the humans. Side effects, and scientists would have taken at least 6 years. A group of scientists would have taken at least 6 years to discover a medicine that can cure, that can be used for various different applications. They're still looking at applications, but antibiotics are not easy to find. And that the AI application through pattern searching, through medical, could find it in 3 days. Similar application, I heard they found a P5 protein that suppresses cancer 50% of the cancers that particular protein can suppress. And that was discovered using this pattern search through the medical journals. It's a very, very powerful technique. So the use case is clear why AI is a game changer. Now, I was just showing you Google and NVIDIA, but there's a lot of big companies who have actually invested big time already in Gen AI. Microsoft is another one. All of them are going big. So the question is, do you want to be part or do you want to jump on it? I'm personally sold on it, but do your research. But this is something why I think it's a game changer. Fasten your seatbelt. This is one piece I want to suggest. Safety is very important. AI power is available to people who damage. AI data is all biased. Anything you do in your domain, if it becomes public, that's a problem. The confidentiality matters. There are a lot of issues there. So safety is very critical. Risk needs to be managed properly, especially, and I'm very big, I'm working with some other organization on responsible AI, how to use it. But this is a piece that's very important, and I just want to highlight here. And so the two things I want to mention here, most CEOs, most organizational leaders know they have to adopt Gen AI. Most meaning close to 100%. But there are only 14% who have the capacity to do it. And why? What's the problem? They don't have enough knowledge to decide what is good, what is bad, what works, what doesn't work, how to use it. So this leadership challenge really is how to know, how much to know, who should know, and how to make decisions about Gen AI. So this is a very key critical, and I suggest typically that be mindful of it. You have to do it right. You have to know all the pieces in the game. The second piece, I said the rate of complexity growing in Gen AI is exponential now. Everything is growing at such a rate. The ability to respond, to create laws, to govern, to have framework. The data is a huge deal now. How do you manage things that you have never thought that verification people have is to find these disparate data and make sure we do it correctly. Our ability to respond to the complexity is not grown. We barely keep up with things. So that's a problem. And I just listed a bunch of things here at the bottom that are typically you will hear about the issues with Gen AI, including the last two we're saying, is it an existential threat to humanity? Can it become so powerful that it's not, it can outdo humans? And those questions I won't answer, but I just listed it here. You can hear about it elsewhere. But some things will matter, and as we talk about it, you can ask questions or I can talk to it towards the end. So let's just quickly look at what works, what does not, and way forward. So it's a different order than what I wanted, but let me just, give me 1 second. I'm going to go back and forth because it's not the latest slide, but let me introduce a few terms here. First is LLM. You have heard it along. It's large language models. It's a text generator, just like your autocomplete on your iPhone. It just figures out what's the next word to output. Just like we speak. When I'm talking, I'm not thinking of what next word is. My brain is working to predict the next word based on the context. LLMs work the same way. So it's a text generator. It works like a simple autocomplete, and it learned the probabilistic relationship of words, and that's how it knows. And the way it learns is by consuming lots and lots of data. And we talked about ChatGPT being millions, and we'll see the size of it is increasing every day. The foundation model is same as LLM. There's some differences, but it's essentially, and it can have other things also. It's a multimodal voice, and it's a large language model focused on language, but the foundation model, which is a bigger, from which the LLM often is a subset, has everything potentially. Synthetic tests I just introduced here because in verification space, I wanted to know, we don't have enough data. So how do you create and validate stuff? So you will need a technology to create a fake data that mimics real data so we can train the model properly. So that's important concept. Just for the purpose of definition, I'll leave you. Go back through it here. And let me go back quickly to this LLM. So LLM is large language model. One of the things, if you talk ChatGPT or any of the chatbot, you'll be very impressed that it talks so uh, coherently. The text comes out nice. If you meet a person who can talk smartly, coherently, we think he's smart. We assume the same is true of LLMs. Because it can talk smoothly and clearly answer you something, you think it's smart. The answers may be total garbage, depending on what it finds in the pattern. If it found something good in pattern, it will make sense. It found something that doesn't make any sense because it doesn't have the deeper understanding of the meaning. It has just memorized the text. It has memorized millions of books, and it just spitting out things by probabilistically putting things together. So there is a real limit to what it is. So we are amazed how good it looks because it's trained on such a large amount of data, but it has its own. And you heard about hallucination as part of the issue. Perform memorization is what it does extremely well, but its predictions are probabilistic. It can't reason logistically. It's not a deductive, it has no deductive reasoning capability. It doesn't understand the symbolic structures there. It only does inductive reasoning. And so when you have some logical questions, it's going to fail. There are some things it doesn't do. It doesn't do math. If you have math problem, it can't do that. So there are some serious limitations it has, but the very fact that it can understand English language or any natural language and come up with an answer is a very big deal. So some of these shortcomings, and the right side I just gave you an example, can be taught. And the way we taught, I'm going to talk a little bit more about how we talk about it. You can help it with context. You can help it with some planning, decompose the steps for it, just like you will teach a little kid. If he doesn't know the answer, you will break down the steps for him. Can you do this first? Then you do this. You lead him to the answer. He will come up with the answer, but you lead him to the answer. So some processes are in place. If you can put it, you can provide feedback. You can give better context. The quality of data itself matters. If it has a better data to work with, it might actually do a better job, but only to certain degrees. Some of the hallucination can never be done. RAG is a concept, I'll talk about it. It does improve accuracy and hallucination for the knowledge-based stuff. It can't do deductive reasoning, but it can produce some results that are very, we'll see, especially for something like our work, for very long-grade work, for specification, and it can improve and give you better results. And there are many more methods that I won't talk about it, but I just want to mention that they are there. So this is a typical flow. Quickly, just look at three pieces here. I'm going to talk a little bit more about what those things is. The top part is your application, the chat bot or an agent we'll talk about. Something where you enter the question and answer pops out. So that's the purple part. But underneath, there is an LLM or a foundation model that has been fine-tuned through some training, some other stuff, and I will talk about what is fine-tuning and so on. And on the left side is something that LLM doesn't have, like your private domain. If you're working for, say, ARM or AMD or NVIDIA or Google or Microsoft, you have a lot of proprietary data. That's not part of LLM. LLM only contains today the public knowledge. So how do you feed that piece? Because the answers doesn't exist in the LLM. So that's the green piece. I'm going to talk about it in a moment. So you feed your PDFs in the green, which is the raw data. It stores it in some way, and it feeds it into the application, and it feeds it into the LLM, and we use the LLM machinery to get the answer. So all the search mechanism or search matching, semantic matching that is done by your engine is utilized from the LLM, but the data is coming from the outside source. And then there's the right side, I said monitoring, and there's a place for human feedback as well. So this is my simplified conception of all the application that you see today. The purple is application. Underneath, think of this blue block and a green block, which is helping the purple piece. So we just talked about it. I had jumped to this just to talk about model. So look at this 4 things here. Prompt engineering. Teach LLM to respond to, again, I'm going to rephrase it because I don't have the latest slide here, but bear with me. So how do you create a well-crafted query? That's the definition of prompt engineering. When you ask a question, it will give you a response. You may not like the response necessarily, but if you ask it nicely, if you give it a proper context, if you can base your query or a prompt in a way that LLM has a bigger context to work with, then it comes up with a better answer. So that guidance is a necessity to work on this stuff. So RAG interval, adding knowledge from external source. This is the key for feeding new PDFs. So if you have a verification plan or you will be using RAG. RAG is called retrieval augmented generation. This happens when domain knowledge that doesn't exist in LLM needs to be part of your answer. The answer exists there, but you don't have it. Then you use RAG. Reinforcement learning is just aligning that output to your preference. This is something, just wanted to throw it as a definition. Fine tuning, I'm going to talk a little bit more, but anything post pre-training, when an LLM or ChatGPT comes, it comes with the training. Anything you add beyond that is fine tuning. And the training is just pre-training that comes with it. Prompt engineering, again, you can create the context, set up a level, tone of response. So if you say, tell ChatGPT, please find this answer, the answer that comes back will be more polite than if you just ask the question. So the context is set by the question itself. You can set the tone any way you like. You can say, oh, I'm a researcher. Or you can say, I'm a 4th grader. The answer will come at a level of a 4th grader, or an answer will come as a level of an expert. So you can set the context, you can set up a level, you can set up a tone of response. All these things are part of, there's a whole prompt engineering course just to teach you how many different ways you can set the context to get the right answer. Safeguard filters, you can result that come, you can check, is it a good, it comes up with 2-3 results, you can refine the results, you can create filters to make it more relevant. So this is important to understand. And of course, query is an important part of the prompt engineering. And formatting also you can decide. You can say, oh, by the way, give me the answer in the bullet form, or give me an answer in a paragraph. You can decide, or give me an answer in a JSON file. Whatever you want, the answer can come back appropriately. Or give me a code in Verilog, or write me a code in Python. All those things can be set up. So RAG is knowledge from external source that is not inherently present in LLM. LLMs do not store facts, they store probabilities. It's an important note to know that if you think that it will find, it summarizes things and find the most probable answer as the correct answer. It's paraphrases, but it is read in probabilistic manner. Adding right information from outside can be powerful, especially it's needed for all the proprietary information to be added, which is not part of LLM. Unless you have a NVIDIA like, where they have created the entire LLM that is full of proper information, full of stuff that they want. So that's an option, of course, but this is a piece that will come from outside. So I just want to quickly, briefly, I won't go too much into detail, but the green stuff I was talking about, you feed the PDF on the left side, or a web page, or a spec, or a verification plan, or a spreadsheet, whatever you want, on the left side. It stores it as vector. It is easy for it to search, where the LLM can work on it. So that's the piece, that green piece is now available to the right side, where you have a model access. See, the LLM only knows a prompt and a response, but you added this machinery, and your application can do some pre-process to reformat the question. Some optimizations the pre-process can do, and you get a correct answer. So the answer exists in the green part. Machinery used is in the blue part, and your application is the purple one. So it goes through the process and finds out. So these are the mechanisms you will be using also for various applications. Quickly focus on the left, right top picture. After the pre-training, if you do anything, it's called fine-tuning. So the model comes and you have to modify something into the model because it doesn't quite fit your needs. And this is becoming a trend also because nobody has time to create a model like NVIDIA from scratch. Fine-tuning is much less expensive. RAG is even lesser expensive because you don't even touch the model because you provide that green piece that feeds the information and use the LLM machinery. Here, you can change LLM, fine-tune it to some degree because you'll find it depends on the use case. It will help. So whenever you change even, it has billions of parameters. If you change one single parameter, it's called fine-tuning. And typically for some of these applications, for software development, for code writing, most people change few dozen parameters. Within less than 100 parameters, you can create a custom fine-tuned model for a particular task that is very, very useful. So that's a very good information. So you desired output, you can have, I won't go through the term, but basically the way to train is providing a question and answer pair. So that becomes a training data. If you provided a question and answer pair, you can fine tune the model and you can use some massaging and other reinforcement learning, human feedback to get the output the way you like it. You can teach style, again, this is an old slide, so bear with me. Didn't get updated even, this is not even yesterday, this is a very old slide. So teach style, tone and output formatting. You can bake in, as I was giving an example. For example, you can have your standard code, coding standards. You can teach the coding standards. Suppose you want a synthesizable code. You can teach the coding standards to the model. You can bake that in. And that coding standards becomes the way it will output your Verilog code. So now you have a code that's coming out that is more tuned to what you want. And that baking in coding standards is very, very easy. Yeah. Then you just pass the PDF file through the data and you can fit it in. Domain-specific expertise. So fine-tuning allows for various things and you can optimize for various tasks. The reason I'm talking about RAG and fine-tuning is where the AI is going. These are the two techniques that are very important to understand. And then I'll talk a little bit more about one more thing after that. So fine-tuning, you can do on a small, so there is a cost issue if you go with the largest model available. There are all sizes of models available in the market now by so many different vendors. They are expensive. The ChatGPT-4 is almost 10 times more expensive than ChatGPT 3.5. Very, very costly. So whereas ChatGPT 3.5, along with RAG, along with fine-tuning, can meet or exceed the same level of performance as ChatGPT-4. Then why would you want to pay 10 times more? 10 minutes? Okay. So that's the key here. So smaller models, you can pick a smaller model, fine-tune it for your purpose, and use it for that purpose. The bigger models are slower and expensive. It has its purpose. It has more power, but the power comes at a price. So you have to make that right trade-off. Small trainer model performs better on the specialized task, and you can get the relevant outputs. Let me quickly go through it because I want to go on to my main message here. Does not teach facts, can do smaller data sets, does not have to be too expensive, not too complicated, and it works along with RAG. So skip the bottom lines. I'm going to just focus on the top line here. The agentic reasoning, again, I use the name, Andrew's name, because he's popularized it, but a lot of people who have developed it, it has been there. He has just summarized it. The AI assistant, the ChatGPT, had RAG fine-tuning. There are some other things, like I was talking about the limitations of LLM. You add planning, you add some tools, like it doesn't do math. If you add a calculator, you don't have to modify the model. The if your model can call a calculator, it can do the math for you. So don't want to invest in things that are unnecessary. Focus on things that are necessary. So that's important. And then it has some memory. LLM itself is a stateless. It doesn't have any state. It's too expensive to keep state inside the LLM. Some of the state is in the application. So agent is one of those applications where memory is there, and that memory is used to keep in mind what's in your previous comment. And then you have execution. So this evolution of AI agent, I'm going to skip this slide completely because of time. This is the agent, for example, you have a tools API, plan, memory, reflection. So these are the pieces of agents component. Tools are the function calls that are made in this application. It could be a calculator, it could be a code interpreter, it could be a API, whatever you want to call it. So the tools can be asked to do, basically LLM doesn't do what it doesn't do well. It just delegates it to the tool. The tool does it for it and it comes back. And it uses that information to give you the correct answer. So you plug in the tools in the agents. So the agents are very powerful. Planning is plain chain of thoughts. Again, chain of thoughts is a way of planning that is available in prompt engineering or anyway. So you can have a planner inside the agent that does it. Reflection is a way of repeating. For example, you wrote a code and you expect it to work. Rarely happens. You will have a buggy code. You will revise it. Reflection is a way for LLM to do that. You basically ask him, write the code to do these things, to the multiply to numbers or whatever it is you want. It writes the code. Then you say, can you see if there is a problem in this code? You take that code, cut and paste again, and ask it to redo it. It will find a way to improve the code itself. Just like you do it, LLM does the same way. That's called reflection. So nothing, no extra work, just simple cut and paste allows you to do that. So somehow you can find a way to reflect and improve. LLM can find its own mistake better, but cannot generate the correct output the first time. So you ask him to repeat it. Sometimes you ask him to break down. Can you stepwise go slow, take 5 steps, explain the reason? It will do that for you. And then it will come up with a higher quality output. And the memory is something it needs to retain the information from the previous comment and so on. And that's a piece of it. So this is something I wish I had a newer slide, but good. So Sinfonia Digital is another platform. If you look at the www.sinfonia.digital, this is part of the Planorama design. They have a Planorama Labs where this is a virtual assistant where you can talk and get help on the Verilog or verification related stuff. There's a demo on the Sinfonia Digital. You can go look at it. It's on YouTube. It's a RISC-V demo. It shows you how it accesses information that is dispersed across your organization. It talks you about how the test is generated, how the test plans are reviewed. It will review and it will show you how it found the gap in the test plan. Matt, who created the demo, forgot to add certain instructions. It says, oh, by the way, you didn't do this piece of the test plan and the spec don't match. There is something in the spec, but you didn't have it in the test plan. It introduced the bug, it found the bug. Again, it's a toy example in many ways, but it's a very important piece to demonstrate the technology. And there's when you find a bug, it immediately points out to where in the spec the problem issue is and connects you to the easy retrieval. It generates the Verilog code for you. It generates the SV assertions. It just reads the specs and creates assertion for you. You don't have to write assertions anymore. And it's a brainstorming partner, which is a huge deal for less experience or even for an experienced person. You can have a designer there you can ask it to play a role of a designer because it knows the spec. It can play the role of an architect and so on. So, and there's a new way of thinking about the automation here, and we'll talk about it a little bit there. And we're working with some big semiconductor org to enable their verification flow. So this is what it looks like. If you look at the bottom part, all those part of the is demonstrated in the demo. It has access to RTL repo, spec docs, test case repo, verification test plan, and it generates the test, it generates the assertions, creates it. The right side, the code coverage and functional coverage can be linked in. We're working with some customers there to enable that, but that's creating the whole automatic flow, complete enablement. let's quickly go through. This is a paper where this is in the Romanian journal. They feed the timing diagram, and it spits out the UVM code. So this is where AI is getting. So are your job replaced? No, you still has to do some massaging to get it right. But this is a research as part of her PhD dissertation, where she generates the UVM code from specs directly. Now, our demo shows RISC-V, but the reason I'm showing this picture is that it's the same story with the UVM. It doesn't require any additional. So we are going towards full automation. These are some of the other points I'm not going to go through, but different companies are using AI for various purposes. These are some examples. So if you are not, I want you to think again. Where is data? This is the slide from the last year. I talked about verification by documentation. This is just one of the slides from there. It has some. It's everywhere. So data is throughout, and that's what you need for AI. So if your documentation is good, if data is cleaned up, you have a much easier job creating the verification. So here's the future painted by OpenAI. Their next ChatGPT, I think it's called ChatGPT Next, is probably coming out next month, very soon. They're saying they're at a level of reasoners. So reasoning, as I said, I was showing you how you can augment LLM with reasoning capability. So that's where they're headed. Agents, when they say agents, they mean fully autonomous. When I'm showing agents, the human is in the loop. He's helping you through the process. And the human oversight is very critical. And this will continue to be the case for some time to come. But soon, the agents will talk. And eventually, the whole organizations will be there. And this is where I see the future of verification, where you'll have a design spec reviewer. There is a test plan writer. None of these are all AI agents using the technology we talked about today. They're going to do the work for you. You are going to be facilitator to make it all happen. And this is a very, very powerful future if you think about it. And this is happening in the software world at a toy level. It was toy level maybe about 3 months back. People are actually using some of it in the real world already. They have multiple agents working and collaborating together. And the architecture for this is very simple. This is the last couple of slides I'm going to focus, Mike, and I'll close it. Okay. So everything feeds on data, so your data is critical. The quality matters. You need to clean up. And again, protect your data, but confidential. The other thing's important, and the bottom line here is the reskill. Every engineer should learn AI. I think this is not an option anymore. The reskilling is a critical task. Defining new verification architecture that will use agents. And you need a framework for managing data because they're going to be there, and you have to have collaboration with other people and so on. Because data could reside at the customer side, data could reside at another organization, data could be everywhere. And you will be responsible for all the legal ramification. If the model screws up, you still own the results. So ultimately, at the end of the day, what matters is this thing. Start with the easy pilots, and that's in the demo. New verification architecture, everything will change. The work, tools, everything is changing. The process will change. And the change management, if you think about it, the culture will change, organization will change. So this is very, very critical for companies. So here's the thing. There are easy pilots that I talked about, is a spec plans gap review. It's in the demo that you will see. Test generation gaps, debug coverage. These are easy things. But going towards the agentic flow, where all the agents autonomously working, using verification agent as your partner engineer, as a colleague, is very critical. So all three things are important: reskilling, retool, and reorganize. With some contact information, this is basically.
Okay.
Thank you.
Thank you very much.